We're going to talk about collecting like terms, and so first we need to define a like term. A like term has identical variables. And that includes the exponents on the variable. So if you have identical variables, so like 3x and 5x are like terms. 2x squared and 6x squared are like terms. 5x and 2x squared are not like terms. Okay, so the variable has to be the same, but then also any exponents on the variable has to be the same. But then numbers are like terms, so 5 and 10 are like terms because they don't have a variable. Okay, so collecting like terms, this is also known as simplifying. And that's just adding up the terms that match. Okay, and you can do that without variables too. I can do it with fish and bicycles and unicorns. And that's what I call like collecting like terms. Like the reason I can't add a 3x and a 4y together is because a 3x is like 3 fish and a 4y would be like 4 bicycles. And if I put them, I can put 3 fish and 4 bicycles in the same maybe big giant container, but they don't become fish bicycles, right? They're still fish and bicycles. There's not some weird mutated fish bicycle, right? So that's what like terms are like. You can put them in the same box, but if they don't match, they don't suddenly become some new funky thing that's a combination of the two. So if I have 3 fish, that matches negative 18 fish. So how many fish do I have? Well, I do 3 plus negative 18 fish. Okay. And if I have 2 bicycles and 5 bicycles, I'm going to do 2 plus 5 bicycles. And then the poor little unicorns are over here by themselves. Okay. So what I have is 3 plus negative 18, so I have negative 15 fish plus 7 bicycles minus 3 unicorns. And I can't combine fish and bicycles and unicorns to make some new unihorned fish cycle. Right?
Right.
Yeah, there's no such thing as a unicorn fish cycle. Okay. Let's do some of these. 2y minus y.
Yeah. Y?
Yeah, just y. Okay, I have c and negative 5c. Like if you want, if it makes it easier to, you can rearrange things. Just remember that if you have a negative, it has to stay with whatever it was attached to. So if you like to put things together and rearrange it so all the letters that match are next to each other, you can do that. Yeah.
Why is 2y minus y?
Okay, so there's an invisible 1 here and here. We just don't write the 1 because this is saying 2 times y and this is saying 1 times y, but 1 times y is just y because 1 times anything is itself. So we leave the 1's off, but they're there. So if you see just an x or just a y or just a z or something, it's a 1x, 1y, 1z. Does that help? Okay. So this is 1c here. So there's that invisible 1 right there. So I have 1 minus 5, negative 4, and then 2 plus 1. So 3d. And that's as simplified as it gets because I can't mix. This would be like cats and that would be like dogs, and unless you're a Nickelodeon cartoon, there's no such thing as a cat dog. Right? So, okay. P squareds match p squareds. So there's a p squared, and that's it, right? Q squareds match Q squareds. And poor little by himself P is all alone. And like I said, if you want to rearrange them to write them together, you can. You don't have to. Some people like to, some people don't. Minus P. If you do rearrange them, it can be helpful as you write. So I go, okay, 11P squared, and then minus P squared, 6Q squared, plus 6Q squared, plus Q squared minus P, and just make sure you got everything. If it's a long string, so that you don't get the wrong answer, not because you did it wrong, but because you left something out. Okay, so then 11P minus P, 11P squared minus P squared is 10P squared. 6 plus 1 is 13. And then I have that minus P that just hangs out because he's by himself. So he doesn't have anybody to combine with. Okay, so I call this section making sure we all get the same amount of ice cream. Anybody have siblings? Did you guys argue over she got more than me or he got more than me or no? Yes, okay, I have a yes. So that happens. So we're going to use the distributive property, and the distributive property is making sure that everyone gets the same thing. Okay, so distribution, if you talk about in general, is to give out something. We can distribute flyers, we can distribute mail, we can distribute food. You know, we can distribution is to hand things out to everyone or every part. Okay, if I'm distributing flyers, I want to give one to everybody, right? So, and it doesn't do me any good to give one person 10 of them and then another person doesn't get some. All right, so we have the distributive property of multiplication over addition or subtraction. That's the really long word, but we only ever call it this, the distributive property. So you can write down just the distributive property. Technically, this is the title, but, and it goes like this. If I have A, and I multiply that times B plus C, that's the same as AB plus AC. And if I have A and I multiply it times B minus C, that's the same thing as AB minus AC. And that's confusing. So let's use numbers. 3 times x plus 5. I'm going to take this 3 and I'm going to multiply it by x, and I'm going to multiply it by 5. 3x plus, 3 times 5, which equals 3x plus 15. The most common error I've seen with this is that somebody will multiply by the first term and forget to multiply by the second. And so they'll just write 3x plus 5. So just remember, you have to multiply by everything inside the parentheses. You're distributing the 3 to every single thing inside. You're making sure that if the 3 is ice cream, both x and 5 get some, and they get the same amount. Okay, so distribution. I'm going to distribute this 4 to both the 5 and the negative 10. So 4 times 5x minus 4 times 10. You don't have to write this step in if you don't want to. I just want to make sure everybody sees what's happening. So you get 20x minus 40. When you're distributing and you have a negative, that negative has to come with the 3 or whatever number's here. So this is negative 3 times negative 11y, and then negative 3 times negative 8z. So that's negative times negative is a positive. So I get 33y plus 24z. And sometimes you get this little negative outside by itself. That's really little negative. Let me make it a little bigger so it's really obvious it's a negative. Okay, so there's a negative. We distribute that too. And we're just going to change all the signs. So to make the negative to the 4x makes it a negative 4x. This was a negative 2y, so it becomes a positive 2y. This was a positive 8z, so it becomes a negative 8z. Well, just like everything in math eventually gets more complex. If you are multiplying by a fraction, okay? So when you multiply by a fraction, okay, actually it's multiplying a whole number. So if you're multiplying a whole number by a fraction, the first step, or actually you can do these in either order, but you're going to, so I'm just going to write it down. Okay, you're going to be dividing by the denominator. You're going to be multiplying by the numerator. Numerators with a U. Okay, so here I've got a 2. So I'm going to divide by 2. So 2 goes into 6 3 times, and 2 goes into 12 6 times. Now I have a 1, so I would technically be multiplying by the 1, but I don't really have to multiply by 1 because it doesn't change anything. So that becomes 3e minus 6f. Any whole number times a fraction. So if I do, let's say, 3/4 times 8. Okay? I'm going to divide by that denominator first if it goes evenly. So 4 will go into 8 2 times. So this is division, except actually I guess it's technically the other direction. It's 8 divided by 4. And that'll give me 2. Okay? And then from there, I'm going to multiply 3 times 2. And that gives me 6. So 4 goes into 8 twice, and then 3 times 2 is 6. Want to see another one like that? Okay. Here, I'm just going to add another sheet. Not 15. That'll give me the same answer. 2/5 of 20. Okay. 5 goes into 20 4 times. So between these two, I'm dividing. Okay, 20 divided by 5 is 4. And then 2 times 4 is 8. Okay. Now, if the denominator doesn't divide evenly, so if I did 2/3 of 10, well, 3 doesn't go into 10. So it doesn't divide evenly, so I'm going to skip the division part and just do the multiplication. And I do 2 times 10 is 20 thirds. And I carry this denominator and I just bring it over because it won't divide evenly. Want to see another one like that? Yeah? Okay. Let's do 3/4 of 9. 4 doesn't go into 9, so I'm going to do 3 times 9, and that gives me 27/4 because I just bring this 4 over. I'm multiplying 2/3 times everything inside, so the first thing I'm going to do is I'm going to say, okay, do all of these divide by 3? Yes, they do. So I'm going to go through and divide them by 3. So 3 goes into 6 twice, 3 goes into 15 5 times, and 3 goes into 9 3 times. Good so far? Then I'm going to multiply each of these by 2. So 2 times 2 is 4, and that x squared is still there. 2 times 5 is 10, and there's that y, and then 2 times 3 is 6, and there's the x. Other things, they can be really long. It can be a lot more than 1 or 2 or 2 or 3. You can have, you know, an infinite number, not that you'd be able to work it out, but you could have any number of terms inside the parentheses. So I'm going to do this real quick. I'm going to distribute this negative to every single thing. So whatever amount of terms are inside here, you always multiply by every single thing inside. So this one is just going to change the signs. Oops, plus. I said change the signs and then I didn't. So that's a plus, and then this will become a minus. This will become a plus, and that'll become a minus. And then finally, the number can be on the back, or whatever you're multiplying by can be on the back. So you're doing the same thing, you're just distributing in backwards. Okay, now this and this are two different things. This is minus 3. This is times 3. So if there's a plus or a minus in between, then you're not distributing unless there's a parenthesis. So I have 3 times negative 6 is negative 18, and 3 times 5 is 15. Okay? Questions on that at all? First set we have are the natural numbers. Okay? These are also known as the counting numbers because you start at 1 and you go 2, 3, 4, 5, forever and ever and ever. Okay? And you can symbolize it by writing an N with a little line thing right like that. 0. Yep, I didn't record that. Okay, so whole numbers start at 0. That's the only difference. So the natural numbers are smaller than the whole numbers, and they fit inside the whole numbers, but the whole numbers only have one extra number. Okay? And then those fit inside of the integers. Okay? So that's our next set, our integers. Okay? Symbolized with a Z, a double Z. Now, integers, natural numbers and whole numbers are infinite, but they're only infinite in like one direction. They just get bigger and bigger and bigger. Now with integers, you're infinite in two directions. You have all of the negative numbers, 0, and all of the positive numbers. So this is like twice as big as the whole numbers. I mean, they're all infinite, so it's kind of hard to say that, but you can see so far we're building, right? We're building up and building up. Now the integers fit inside of the rational numbers. Okay, now the rational numbers is symbolized by a Q with a line in it. I don't know where the Q comes from. Sorry. This is all fractions. Okay, that is actually the definition of a rational number, is a number that can be written as a fraction. So it's all fractions, it's all integers, and it's all decimals that end or repeat. Okay. Now, the real number system is kind of like a family. You know, you have your family and they fit together. And then, you know how every family has like crazy Uncle Junior, crazy Uncle Joe, crazy whoever, and they're part of the family, but they don't really fit. Okay, that's the irrational numbers. And irrational numbers are decimals that never end or repeat. These are numbers like pi, square root of 2. Any number that's not a perfect square, typically speaking, won't ever end or repeat. So he's in the family, but he doesn't really fit in with the other guys. But they are all in the same family, and that is the real number family. So these are all real numbers, which is symbolized by a double R. Oh, and irrational numbers are symbolized with a bold I. Every property that we're going to talk about from now on, properties of real numbers, apply to everything in here. It applies to integers. It applies to fractions. It applies to decimals, whether they end or repeat or not. So these are properties of real numbers. Now, we have real numbers, and then we have imaginary numbers. We're not going to do those yet, but they come up in Algebra 2. And that's the difference. There's real numbers and imaginary numbers. But real numbers all follow the same properties, no matter which of these circles or hexagons or whatever they're in. Is anybody still... So real numbers all satisfy the same properties. They are reflexive, which means they have this property. A equals A. 2 equals 2. Okay, you can remember reflexive property because it looks like a reflection. Okay. They are symmetric, so 3 plus x is equal to x plus 3. It's like a reversed image across the... Does it make sense? Okay, transitive. If x equals 5 and 5 equals 3 plus 2, then x equals 3 plus 2. Okay, now transitive and substitution look very similar. The difference between transitive and substitution is, do you see how this is 5 and 5 right here? Transitive will have that, 5 and 5, or x and x, or 3 and 3. You get the same thing on either side of the and. Substitution, if x equals 5 and 3 plus 2 equals 5, then 3 plus 2 equals x. Almost the same thing, but it's different. Or you can say if x equals 6 and x plus 2 equals 8, then 6 plus 2 equals 8. Things like that. You can take one thing out and put another thing in. If you think about substitution, substitution is kind of like giving change. $1 is the same thing as 4 quarters. If you have $1, you don't really care if you have a single dollar bill or if you have 4 quarters, you've got $1. It doesn't matter which one. So I can put, like in the machine downstairs, I can either put in the $1 or I can put in the 4 quarters. It's got the same value. I can substitute them for each other. These are the properties that actually get used the most. Substitution, and then we have commutative property. And commutative property is that A plus B is equal to B plus A, and A times B is equal to B times A. The order you add or multiply in does not matter. Now, I'm only using addition and multiplication because the order you subtract or divide in does matter. So these only work for addition and multiplication. When we were doing the like term and we were rearranging them, that's commutative property. Commutative property allows you to rearrange problems to make them easier. That's the whole point of commutative property, is so I can take, if there's some other stuff going on, I can move things around to make the problem easier. But again, and that's why I had pointed out that if there was that negative in front, you had to bring it with you, because 5 minus 3 is not the same thing as 3 minus 5. But 5 minus 3 is the same thing as negative 3 plus 5. Does that make sense? Okay. Then we have the associative property. And okay, so commutative. Do you know, think about your commute. Oops, commute has two M's. I go to work. Oh, wait, actually, let me do this. I go from home to work, and then I go from work to home. All I've done is change the direction. That's a commute, right? You commute back and forth. So that's commutative property. All you've done is change the direction. Associative property, associations are groups, right? We have the National American Heart Association. It's a group of people that work on hearts, yeah.
So how do you point out that you spelled commutative wrong?
Here?
Is it commutative? Or?
Okay, no, it's commutative.
Oh, okay.
Yeah, commutative. So associations are groups, and so what the associative property does is it changes the groups. I can say A plus B plus C, and that is the same thing as A, plus B plus C.
In my other math class, we're doing this, and Miss Alice basically says that commutative is numbers that move.
Mm-hmm.
Associated is parentheses.
Yeah, that's what I was going to say.
Right?
Yeah, same concept. However, you can have a commutative property that moves parentheses. So, in general, if the parentheses have moved, here's the thing. If the parentheses have moved but the numbers are in the same order, it's associative.
Right.
Commutative changes the order because you could have a commutative property that moves parentheses if I had like A plus B plus C is equal to C plus A plus B. See, the parentheses look like they moved, and they did, but we changed the order between this and that. Do you see how A and B are still in the same parentheses?
Right.
That's the time when the parentheses have moved, but it's commutative property.
Right.
Does that help?
Yeah.
Okay. So, yeah, commutative changes order, associative changes the group. So, because associations are groups, and so like I could group the class. I could take you and I could group you by girls and boys. Or I could group you by the people on the right and the people on the left. I'm changing the groups, but it's still the same number of people. So that's what associative property does. Identity. You know what your identity is, right? That's you. You have your own identity. Your identity is not changing. That's what the identity property does. It doesn't change the identity. So you have the identity property of addition. And that is anything plus 0 equals itself. I add 0 all day long and I didn't change A's identity. Bless you. And of multiplication. I multiply by 1 all day long and it doesn't change the identity.
So numbers have to do with 0 or 1.
Yeah, and 0 is called the additive identity and 1 is called the multiplicative identity. If you just say identity, that's fine. You don't have to know the word multiplicative, even though it's fun to say. Okay, so identity property is just the things that don't change the identity, and I wanted to do this and I guess I forgot to type it in. And then you have inverse of addition and of multiplication. The inverse of addition is negative. Actually, I'm going to write it. Okay, these two are inverses. A and negative A are inverses of each other. They're also opposites. Of multiplication, it's reciprocal. So if you're talking about addition, the inverse is the negative or the positive, depending on what you started out with. And if you're talking about multiplication, the inverses are flipped over. And then we did this one, distributive property of addition, or multiplication over addition or subtraction. So A times B plus C and A times B minus C. Okay, 5 plus 0 equals itself. Here's what I'm looking for here in the middle where it says 5 minus 4 and 5 minus 4.
Substitution.
You
That's
could,
transitive.
it's transitive technically, but if you put substitution, I would not count it wrong because they're very similar. Technically it's transitive. Whereas this one, see how it's 2 and x plus 3?
Yeah.
That's substitution. And then if 3 equals 2 plus 1, then 2 plus 1 equals 3, I've
Symmetric.
flipped it around, yeah. Okay, and last one. We're going to name properties that justify each step. So I've got 2 times 93 times 5 is the same thing as 93 times 2 times 5. I did what property? The parentheses didn't change, but what was inside the parentheses, the order changed. It was commutative.
However you say it.
Commutative.
Commutative.
Yeah. Okay, now I've moved the parentheses from here to here.
Associative.
So that's associative. 2 times 5 is 10. That's substitution, actually. I'm substituting in 10 for 2 times 5. They have the same value. Does that make sense? Or you could say multiplication. That's fine too, because that's what you did. And then 93 times 10 is multiplication. Okay, why did we do all that stuff? Well, we moved the 93 and the 2 because 2 times 5 is easier than 93 times 2 or 93 times 5. Right? And 2 times 5 is 10. And 10 times 93 is easy. Just add the 0. Right?
Oh, I see where you're going then. I was like, okay, it's just one problem. And different, okay.
Yeah, it's just the steps of a problem. So we're just using the properties to justify the steps. We're going to go through just this one more and then we'll be done. Okay, so here again I changed the order inside the parentheses. So if I change the order, it's commutative. Okay, and here I changed the parentheses from here to here. Yeah. And if you want to like shorthand the word, that's fine. Just be sure to put the OC in there and don't stop after the second S. Okay. And then 40 times 6, you can just write multiplication if you want.
But would that not be substitution?
Or you can write substitution. Yeah, it's both.
I just want to make sure I'm getting this right. So because we substituted, instead of putting 4 times 6, we substituted it with 240.
Yeah.
Okay, so I'm getting it. All right.
Okay, and there's really no point for what comes after this except to make you do steps. Because really, why would you break this up? It doesn't make any sense. But okay, so 10 times 24, that's another substitution. Or maybe you could say division. Would never ask you to do this in a problem, to multiply things together, then break them back apart. But this is just so you can identify steps. Okay, and then I move this parenthesis from here to here. And then I multiplied these together. So again, you can write substitution or you could write multiplication. Multiplication only has one T. And then 10 times, yeah, multiplication. Okay. So the homework for this one, that's page 9, I believe. Or is it 10?
Do you want us to like take apart the packet and hand it to you? Or
No. It's page 9.
you're not going to collect them? Or?
I collected all at once.
Oh, okay. I thought you said you were going to collect them with the individual ones.
No.